the Columbia River in Washington in the United States. And we're looking at gigantic rock wall of basalt. The eruption that formed this is actually a series of eruptions called a flood basalt eruption. It erupted from a fissure about 20 million years ago, and each layer across there represents a single eruptive event. Now, this occurred 20 million years ago, but it didn't all happen at once. A series of eruptions piled layer after layer of basalt on the rock walls to a depth of a few thousand feet. We're looking at the surface of one of these flood basalt layers. You can see it is marked with all of these holes. These holes are actually formed as gas was escaping the lava as it cooled. As you can see, we're going to go from the surface of one layer to the surface of the next, or to the bottom of the next. And this has very little holes. As we rise up through the layer of this basalt, more and more of the vesicles appear until we get to the surface, and then they are again. Okay, so if you could think about this as kind of like soda bread. The bottom in your pan will be very nice and uniform and hard, but as it rises up and the gases escape, you get all of the vesicles. A couple geologic features here that are pretty interesting. First of them are all the fracture patterns. These fracture patterns formed after these layers of basalt were laid down by the flood eruptions. And if you look, the foothills of the Cascades in the distance, these fracture patterns are lining up parallel to the direction of the Cascade. So when the rising of the Cascades occurred, you had a breaking up, a general breaking up of these basaltic plains. The other geologic feature I wanted to highlight were these strange fracture patterns through here. It seems like there's no rhyme or reason. Well, these form as the basalt is cooling, and as it cools it contracts, and it contracts in a certain pattern that tends to form these columns, okay, with a regular geometric shape.